into a really wild idea, one that basically tears up the rulebook for reality as we know it. It's called the theory of something, and it suggests that, well, that nothing is universally true, not even the laws of physics. Yeah, let's get into it.
Okay, so let me start by asking you a question that might sound kind of crazy. Is any law of physics universally true? I mean, we all learned about gravity, right? Thermodynamics. We treat them like these unbreakable rules for the entire universe. But what if they're not? What if every single physical law actually has an expiration date?
Well, according to the theory we're looking at today, the answer to that question is a simple and frankly pretty shocking no. Not a single physical law is universally true. Now, that is a massive claim, right? So how on earth could anyone justify saying that?
The entire justification hangs on this one really elegant idea. The theory of something says that for anything to even exist, it has to have limits. It has to have a scale, and it has to have a boundary, a point where it starts and stops. If it doesn't have those, well, then it's not really a something at all.
Okay, so to really wrap our heads around this, we need to get familiar with the basic toolkit the theory provides. It's all built on three simple but super powerful concepts: scale, boundary, and, you guessed it, something.
So first up is scale. The easiest way to think about scale is like the arena or the playground, where a rule or a thing applies. So for example, you've got quantum mechanics, right? Its rules totally dominate at the tiny subatomic scale. But up here, at our human scale, the rules of classical mechanics, like, throwing a baseball, are what matter. Different scales, totally different rules.
Next up, we've got boundary. This one's pretty straightforward. It's the edge. It's the dividing line that separates one thing from everything else. A boundary could be something physical, like the surface of a planet, or something more abstract, like the event horizon of a black hole. It's the line that literally gives a something its own identity.
And all of that brings us to the main event. What is a something? Well, if a thing has a scale where it operates, and it has a boundary that defines it, then we can see it, we can measure it, we can distinguish it from other things. It becomes a something. Without both of those key ingredients, scale and boundary, it's just undefined. It's not really there.
All right, so we've got our toolkit, scale, boundary, and something. Now let's check out the rules of the game. These are the core principles that pop up from those definitions, and they basically describe how reality operates from this perspective.
Okay, these principles all kind of build on each other. It starts with definability. Pretty simple. If something has a boundary, we can define it. But that leads to the really big one, limited validity. This is what answers our question from the beginning. Think about it. Newton's laws of physics, they work perfectly for, say, figuring out where a cannonball will land. But the moment you get close to the speed of light, they just stop working. They break down. You've hit their boundary. And that, my friends, is a scale transition. You've crossed over into a new regime where a whole different set of rules, like Einstein's relativity, takes over.
And you can really see how this all locks together, right? It all starts with that core statement at the top. To exist is to have a boundary. From there, you get our three key definitions: scale, boundary, and something. And flowing directly from those are the fundamental principles we just talked about: definability, limited validity, and scale transitions. It's like a logical waterfall, where everything leads to the consequences and ultimately to a really practical way of looking at things. It all hinges on this one powerful idea: reality itself is totally scale-dependent.
So, what are the big takeaways from all this? What are the consequences? Well, for one, it means nothing is absolutely true. Truth itself is always contextual. It needs boundaries to exist. It also means that every theory we've ever come up with has a domain limit, a point where it just stops being useful. And this leads to this amazing idea that reality isn't just one single thing. It's broken up into these distinct regimes. You've got the super weird rules of the quantum world, the predictable classical physics of our everyday lives, and the mind-bending cosmic rules of relativity. Each one operates on its own scale, with its own version of the truth.
Okay, so you might be thinking, this is cool, but so what? How can I actually use this? Well, this theory isn't just some abstract philosophy. It's actually a practical user manual for understanding, well, just about anything.
The entire theory, the whole thing, can be boiled down to this incredibly simple two-step process. Anytime you're trying to understand something, doesn't matter if it's a scientific theory, a political argument, even a piece of art, just ask yourself these two questions. 1, what is its scale? And 2, where is its boundary? If you can answer those, you'll instantly see its limits, its context, and what it really means.
And that leaves us with one last really fascinating question to chew on. If everything,
Every single something in our universe, from a tiny particle to a whole galaxy to an idea itself, is defined by its boundary. Then what lies just beyond it? What's out there, in that space just past the edge of the known world?
And that's our deep dive into the theory of something. So what something in your own life are you going to look at a little differently now? Let us know down in the comments. And hey, if you enjoyed exploring the boundaries of reality with us, make sure to subscribe and share this explainer. Thanks for watching.